In the last video, we looked at solving exponential equations using logarithms. In this video, we're going to look at solving equations that have logarithms in them. So let's look at some examples of those. We're asked to solve each of the following equations. So if we start with A, we've got log to the base 3 of x plus log to the base 3 of 5 is equal to log to the base 3 of the quantity 2x plus 3. To solve this type of equation, we would look to combine logs. We can do that using log laws. Then we simply now rewrite the statement, or if you like, anti-log. So let's go ahead now and look at this one. I've got the same base, so if I've got a sum, I can write this as a product. Log to the base 3 of 5x, and that will be equal now to log to the base 3 of 2x plus 3. I can now make the statement that 5x will be equal to 2x plus 3. So writing this out, 5x will be equal to 2x plus 3. The log of this quantity will be equal to the log of this quantity, therefore the two quantities will be equal. Solving this equation, I'm going to have now 3x is equal to 3 and x is equal to 1. We need to check our values of x now satisfy this equation, and we're not taking the log of a negative number. In some of these examples, we might see that we have solutions that some of them are going to be valid and some of them not. So we can see that x is equal to 1. So log to the base 3 of 5 is equal to log to the base 3 of 5, and we can see that clearly satisfies the equation. Okay, let's look at this next one. We've got log to the base 9 of x plus log to the base 9 of 10 is equal to 3 over 2. So what I'm going to do here is combine logs on the left hand side. Log to the base 9 of 10x will be equal now to 3 over 2. In the first video, we looked at the statement log to the base a of b is equal to c. Therefore, the exponential equivalent is a to the power of c is equal to b. So we know the log is simply the power the base is raised by to give us this quantity of 10x. So we could write 9 to the power of 3 over 2 is equal to 10x. So I've rewritten this as an exponential statement. So I've removed the logs by simply rewriting. Now 9 to the power of 3 over 2, we take the square root and cube. That gives me 27 is equal to 10x. So 27 over 10 is equal to x, or if you like, 2.7. Again, if we look at that, we're not taking the log of a negative number, and that would be entirely valid. Okay, let's look at the next one. Log to the base 4 of x minus log to the base 4 of the quantity x minus 1 is equal to log to the base 4 of 3 plus 1/2. We've got a range of different choices with this particular equation. One thing I could do is write this now as log to the base 4 of 2. So the first way I'm going to do that is now write this. So on the left hand side, I've got a difference of logs, so I can write this as a quotient. Log to the base 4 of x over x minus 1. And we've seen this as one of our log laws. On this side, I'm now going to write this as log to the base 4 of 3 plus log to the base 4 of 2. I've now got a sum, so on the right hand side, I can write log to the base 4 of x minus 1 on the left will be equal to log to the base 4 of 6. So at this stage, I can write now that x over x minus 1 is equal to 6. We can go ahead and solve for x. So multiplying both sides by x minus 1, we have 6x minus 6. So we can see that 6 will be equal to 5x, and then 6 over 5 will be equal to x. And again, looking through the equation, we can see that that will hold. And if you want to work it out, you can show that. Alternatively, we could have just left this as 1/2 and subtracted the quantity log to the base 4 of 3 from both sides. So if I did it this way, I'd have log to the base 4 of x minus log to the base 4 of x minus 1 minus log to the base 4 of 3 is equal to 1/2. So if I factor now, I can just factor this quantity here. Rewriting, I've got log to the base 4 of x minus, now I've got a sum. So I can write this as log to the base 4 of 3 lots of x minus 1. And now we can set that equal to 1/2. So at this stage now, I've got a difference of logs. So log to the base 4 of x over 3x minus 1 will be equal now to 3, the quantity x minus 1, will be equal to 1/2. At this stage, I can now write the exponential equivalent, and that is 4 to the power of 1/2 is equal to x over 3, the quantity x minus 1. So we can write now that x over 3, the quantity x minus 1, is equal to 4 to the half. So we can see that x over 3, the quantity x minus 1, is equal to 2. And from this point right here, we can see that x will be equal to 6, the quantity x minus 1. And we simply solve exactly the same as we did here. So that's two different ways that you could look at that. I prefer to do it this way. I think it's slightly slicker. But if you don't spot that, it's perfectly fine to combine on the left-hand side all of the logs. So you're taking your logs to the left-hand side, using your log laws to combine the logs, and then you're writing the exponential equivalent. Okay, let's look at the next one. Log to the base 5 of 5x minus log to the base 5 of the quantity x plus 2 is equal to log to the base 5 of x plus 6 minus log to the base 5 of x. So we've got now the difference of logs on both sides of the equation. So I'm going to rewrite each side now as a quotient. So log to the base 5, we're going to have 5x over x plus 2. And this will now be equal to log to the base 5 of x plus 6 over x. At this stage, I can simply write now that 5x over x plus 2 will be equal to x plus 6 over x. We have a quadratic equation in x, so we need to go ahead and solve. So if I multiply both sides of the equation by x and x plus 2, we can have 5x squared will be equal to x plus 2, x plus 6. Expanding the brackets, 5x squared will be equal to x squared plus 8x plus 12. Subtracting x squared from both sides, 4x squared. Subtracting 8x from both sides, minus 8x. Subtracting 12 from both sides is equal to 0. This is a quadratic in x, which we can divide through by 4. X squared minus 2x minus 3 will be equal to 0. This factors x plus 1. X minus 3 is equal to 0. We need to check these. X is either minus 1 or x is equal to 3. So let's look at minus 1. Now straight off, if I put minus 1 in here, I'm logging a negative number. I can't take the log of a negative number. Therefore, this is not a valid solution. What I'm going to do is draw two different graphs. I'm going to draw y is equal to 5 to the x. That is an exponential function. The graph will look something like this. Y is equal to 5 to the x. This point is 0, 1. If I now draw its inverse, log to the base 5 of x, so y is equal to log to the base 5 of x. This point is 1, 0. This is only defined for values of x strictly now greater than 0, in the same way that 5 to the x can never be equal to 0. So we can see that this is not, and we'll write this here, x cannot be equal to minus 1. We can put this is not valid. We would go ahead and check 3. 3 will work in this particular equation, as we can see now from that. So just check that you're not taking the log of a negative number. So go ahead and go through with both of your solutions and check that they're valid. So we can see now that that falls foul right there, minus 1, and of course it does just here. So just have some appreciation that while solving this quadratic equation, they won't always be valid solutions. So our one solution is x is equal to positive 3. And if you want, you can put that in. Just put that in and it should make sense and it will hold true. Okay, let's look at this one right here. Now with this one, I've got 2 log to the base 6 of x is equal to log to the base 6 of the quantity 2x minus 5 plus log to the base 6 of 5. So with this one, I'm going to use two different rules. I'm going to use the power rule or power law on the first one to write this now as log to the base 6 of x squared. And I'm going to use the addition one here, So this will be log to the base 6 of 5 lots of the quantity 2x minus 5. So I can now write that x squared is equal to, and we're going to have here 10x minus 25. So x squared minus 10x plus 25 will be equal to 0. That is a perfect square, x minus 5 all squared, so we can see that x is equal to 5. And if we look at that quite clearly, if we've got 2 lots of log to the base 6 of 5, that will be equal to log to the base 6 of 5 plus log to the base 6 of 5, just subbing in x is 5. So we can see straight off that is valid. Okay, let's do this last one now. Let's have a look at that one. So we've got here log to the base 7 of 4x is equal to log to the base 7 of 1 over x minus 6 plus 1. There are lots of different things that we could do with this particular equation, and I'm going to work through it a few different ways. The first way now is to rewrite this, and I'm going to write this as log to the base 7 of 7. So we could write now that log to the base 7 of 4x is equal to log to the base 7 of 1 over the quantity x minus 6 plus log to the base 7 of 7. Combining the logs on the right hand side, log to the base 7 of 4x is equal to log to the base 7 of 7 over the quantity x minus 6. Therefore we can write 4x will be equal to 7 over x minus 6. Multiplying both sides by the quantity x minus 6, we're going to have a quadratic equation. 4x squared minus 24x minus 7 is equal to 0. We're going to go ahead and solve that shortly and look at the solutions and which ones, if any or both, are going to be valid for that particular equation. An alternative approach, log to the base 7 of 4x minus, now in fact I'll write it as equals first. What we can do is write this as minus log to the base 7 of the quantity x minus 6 plus 1. Let's just see what I've done here. I've written 1 over x minus 6 now as log to the base 7, or minus log to the base 7 of now 1 of x minus 6. If I look now, let's take log to the base a of now 1 over x. We could write this now as a difference. We could write this as log to the base a of 1 minus log to the base a of x. If we have a difference when the base is the same, we can write this as a quotient. This is 0. What power is a raised by to get 1? 0. Minus log to the base a of x. Therefore, we can say that this is going to be minus log to the base a of x. And that is a standard result. Log to the base a of now 1 over x is minus log to the base a of x. So we can now write this as log to the base 7 of 4x plus now log to the base 7 of x minus 6 is equal to 1. Combining the logs, log to the base 7 of 4x multiplied now by x minus 6 will be equal to 1. Writing the exponential equivalent, we can say that 4x, x minus 6 will be equal to 7 to the power of 1, and you can see we will get exactly the same quadratic equation when we expand that out. So this now is a result that you can use whenever you're doing an equation like this, or you're simplifying. That's a standard result. Okay, so let's go ahead and solve this quadratic equation. We've got a, value of a is 4, value of b is going to be equal to minus 24, value of c is going to be minus 7. So what I'm going to do is just put this through the quadratic equation rather than trying to do anything else with it. So let's do that. Let's get the calculator up. So we've got minus b, which will be 24, plus the square root of minus 24 squared, which is just 24 squared, minus now 4 times by a, which is 4, times by c, which is minus 7, all over now 2a, which is going to be 2 lots of 4, which is 8. So my first solution, x is a positive quantity, so x will be equal to 6 plus root 43 over 2. Therefore now x will be equal to 6 minus root 43 over 2. We need to check these values. This is the one I'm really interested in now, so let's go ahead and look at that. Now if I look at this as an answer, this is going to give me a minus number, and it's minus 0.278. So if we look now right here, straight off we can see that this is not a valid solution, as I'd be taking the log of a negative number. Therefore this one now is not valid. So we can say not valid, and then our positive quantity, and we'll just get a rough approximation of the magnitude of that. It's going to be probably 6, something around there. Let's just do that. Let's do plus. What's that going to be? 6.27. So we can see that this is going to be our solution right here. And we could go ahead and check that. So we've got this quantity. So it's 6. So we can see that's not going to give us a negative number. And that is what we'd need to do. So do the maths, but ensure that you are thinking logically about the solutions, because you will be penalised if you put something that's not valid. We know that we can't log a negative number and get a real value. So do check that. So that's a bit tougher, using the quadratic equation to solve and then checking our answers. Okay. What we're going to do is look at one final question. So let's just move on and look at this one right here. So this time we've got log to the base 3 of x minus 2 lots of log to the base x of 3 is equal to 1. So this time we've got now different bases. Now with this we can change the base. We've seen that log to the base a of b can be written as log to the base c of b divided by log to the base c of a. This was in the video on the change of base formula. One of the results of this was if we have now log to the base a of b, we could write this now as 1 over log to the base b of a. So with this particular one here, we can do two different things. One way will be slightly easier than the other. So what we could say now is log to the base 3 of x is equal now to 1 over log to the base x of 3. Alternatively, we could say log to the base x of 3 is equal to 1 over log to the base 3 of x. Now, if you look at the equation that we've got here, it would seem better that I chose now this particular approach. And I'll look at it both ways, but I'm favouring this one. So what we're going to have then is the following. Log to the base 3 of x minus 2 lots now of 1 over log to the base 3 of x. So all I've done is made the substitution, and that is equal to 1. At this stage, if you're not confident, you can say let p be equal to log to the base 3 of x. We've got p minus 2 over p is equal to 1. Multiplying through, p squared minus 2 will be equal now to p. So all I've done is multiply through the equation by, let's just get that, by p. We now have a quadratic equation, p squared, so let's put that in, and that's going to be equal now to p. So p squared minus p minus 2 is equal to 0. So we're going to have p plus 1, and then we're going to have now p minus 2 is equal to 0. So let's now consider what we've got. We've got p will be equal to minus 1, or p will be equal to 2. We know that p is equal to log to the base 3 of x, so we can say log to the base 3 of x will be equal to minus 1, or we've got now log to the base 3 of x is equal now to 2. So these are possible values. Now we just need to be a little careful here. Let's just consider the exponential statement. If we think about the exponential statement, we can say now that 3 to the power of minus 1 is equal to x. So therefore we're going to have x is equal to 1/3. If we look at this one, we've got 3 to the power of 2 is equal to x. Therefore now we've got x is equal to 9. So we've solved it that way. And again, these are both valid solutions. That's perfectly fine to have those. But all we've done is a change of base. So this time I've written it like so. Now, we could have gone the other way. What I've done is just written it in this form. I could now have written log to the base. So instead of writing this now, let's just go ahead and do that. Let's do that one. Let's choose this one. What I did here was used this substitution. If I went the other way, what I could have now, and I'll just rewrite this, I can write this here as 1 over log to the base x of 3 minus 2 log to the base x of 3 is equal to 1. So let's let q be equal to now log to the base x of 3. So what I have is 1 over q minus 2q is equal to 1. So 1 minus 2q squared is equal to q. 2q squared plus q minus 1 is equal to 0. So straight off we've got a slightly harder quadratic to factor. We can see that this is going to give me now 2q minus 1, and then we're going to have, what's that going to be, q plus 1. So let's check our factoring. That looks pretty good. So we're going to have now 2q squared plus 2q minus 1. So we can say that q will be equal to now positive 1/2, or q will be equal to minus 1. Now don't worry that q is a negative number. That doesn't mean that it's not a valid solution. All we do is go back now and look, and we've let log to the base x of 3 be equal to q. So log to the base x of 3 is equal to 1/2. And then this one now, log to the base x of 3 is equal to minus 1. So if we rewrite the equivalent statement, x to the power of 1/2 is equal to 3. And that, of course, is going to give us now that x will be equal to 9. If we look at this one, x to the power of minus 1 is going to be equal to 3. Therefore, x will be equal to 1/3. And that gives us now the same answers as if we went the other way. I just think working it this way is significantly easier, and it just gives you a slight bit more confidence to do it that way. So there we go. That's now solving log equations. We combine logs, and then we simply now rewrite it as an exponential statement, or we anti-log. We check that our solutions are valid. We can't log a negative number to get a real value, so we do need to check them. So in the next video, we will look at some simultaneous equations and work through some of those.